Thanks for that, appreciate it. Hey everybody, thanks for coming. Super honored to be here. I'm Nick Matthews. I'm a Principal Solutions Architect with Project Kuiper. So for those of you that haven't heard of Project Kuiper, we're going to learn all about space today. We're also going to talk about networking, which is my favorite thing in the whole world. I've actually been asked many times over this last week, what do you do here as a solutions architect for something that's still being built? And the answer is, I work with customers all over the world. So, everywhere from Europe, Middle East, Africa, Australia. I can tell you a little bit of some of my trips this week in Port Hedland, but we'll get into that a little bit later. But the answer is, I help customers figure out what Project Kuiper is, what the use cases are, and what it means to them. And so that's what we're going to do today. We're going to take space back down to earth to hopefully mean something to you all. So what Project Kuiper is going to do is provide high bandwidth, low latency connectivity to customers around the world. For those of you that have internet, this is nothing new. You know, businesses are used to having high throughput, high secure connections. The part that's different here for Kuiper is the word global. So we're going to have connectivity almost anywhere on Earth, up to a gigabit. So we're changing the way that people will connect around the world, and we're going to customers and saying, what would you do with that? If you could connect anywhere on Earth with high-speed connectivity, what would that do to change your businesses? What would that do to change your customers, your users? It can be surprisingly difficult for people to answer that, because if you've never had connectivity or never had good connectivity, sometimes it's hard to imagine a little bit of what's possible. The way we're going to do this is with the Kuiper constellation. So we're going to launch 3,232 satellites out into space. I think it's the largest project going on in Amazon, but sometimes it's hard for me to tell. It's a very large undertaking for us. And you know, if you're interested, this is actually over 3 different orbital shells. We'll talk a little bit about that later. But it's worth backing up a little bit and asking, how did we get here? How did Amazon start to think about this as a problem space we want to get into? One of the interesting parts of Amazon is the way that we think about things, particularly things that are in the long term. So one of the first things that we do, this is true across shopping, Kindles, everything we're doing to satellite connectivity, is we start with the customer first. So customer obsession is super important with us. Those of you who have worked with Amazon for a while hopefully recognize this. It's also why we're doing sessions like this and we're talking about things, because we want early customer feedback. One of the things I do almost every day is I go into our product and engineering teams and I'm asked, what do customers want? What are they looking for? We're doing something brand new that maybe hasn't been done before, and how do we solve these problems? So we're getting lots of customer feedback from all types of industries across the world, and really truly taking that into account. And we've actually started to see that in some of the things that we've built. We're changing the way that we're building our satellite constellation based upon early customer conversations. It's super interesting to work with customers and hear what you want to do. The other part is really around this long-term thinking. I started with AWS about 8 years ago, and back then cloud was not kind of the same thing it is today. Everyone wasn't sure if it was going to work or not, but Amazon was investing lots and lots of money into buying real estate for cloud computing, doing research into virtualization and computers. And we did that because we knew it was the right thing to do in the long term. And we believe the same thing is true for Project Kuiper. We think that providing high-speed connectivity to the world is the right thing to do, and we have reasons to be in this business. Now, rockets are a little more ostentatious than building computers in a data center somewhere, so people are paying a little more closer attention to it, but we do think this is the right thing to do long term. And a little bit of history on this, and the commitment is we've committed the largest procurement of heavy launch vehicles ever. So this is over 80 different launch vehicles taking these over 3,000 satellites into space. So this is the type of investment, we're talking about billions of dollars here in order to make this project successful. And the first question I usually get from folks is, when is it going to be available? I've been sitting in the booth, it's the first question we get from every single person. And so I can show you a little bit about this simulation here. What we lack in satellites, we make up in simulations. So what you'll see here is the satellites launch. Each one has a certain amount of satellites in it, and those go at an inclination rate that go over Earth. You'll start to see these bands of density get formed. Those bands start to exist up in around the 52-degree latitude area. So that's around US-Canada border, Central Europe, and Japan. So those are the first places where we start to get enough density to provide production coverage to customers. Then as the more satellites start to go up into space, you see that beam go towards closer to the equator. So this happens over a number of years, but the answer is we'll be doing customer trials at the end of this year, so end of 2024. At mid-2025 is when we have commercial service through North America, Europe, and Japan. Australia follows that fairly closely. The bands start at the south and come up to the northern Australia area. So stay tuned, and we'll be out here next year, hopefully with more details about that plan. Amazon is in space. We have satellites in space. We did the Protoflight satellite launch last year, but again, talking about long-term thinking, this started back in 2018. So the folks that were building Kuiper started back then, and that's when we pen to paper, figured out what this business plan was going to look like. I kind of want to show you a little bit of what the launch looked like for us, because it was 5 years in the making to get there. So I was told people like rocket launches, so I'm going to show up a quick video real quick and go through that.
This is my Operations Center, and today's launch is an exciting step for Amazon's Project Kuiper.
Launch sequencer start.
Go Atlas.
Go Centaur.
Go Kuiper.
You have permission to launch.
Proceeding with the count.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket, carrying the Protoflight mission for Amazon's Project Kuiper.
Mach 1. Vehicle's now supersonic. Everything's looking good. We have exited the Earth's atmosphere.
We go ahead and...
Yes, can run in parallel.
Copy.
2 minutes to contact.
Just wonder if she is alive.
Progressing nominally.
It's nominal on both Proto 1 and Proto 2.
Huge milestone. We got contact with both satellites. Both of them are alive. Still a bit to go. Take 5 minutes. We'll come back at 11:59.
So it may not have come through in the video, but we were all somewhat terrified the entire time. Space is hard. There's a lot of things that could have gone wrong. We were worried about losing satellite connectivity, rocket explosions, you name it. And the relief that came over our entire team was immediate. However, we still had to wait to make contact with the satellite. So it took 43 minutes or so after the launch for us to make contact with both satellites. We may have to make sure, for example, that the solar arrays are deployed. If the solar arrays don't deploy, you've got something that's going to be in space for active maybe a few minutes before it loses power. And so we got connectivity to the satellites. Those worked. All the things we've been testing on ground for 5 years worked. It was a huge milestone for us. And that's also given us now the data and everything else we need to progress with Kuiper. So we've been testing those satellites last year, and 100% of those tests passed. So that means we can go produce production satellites, and that's what our teams are working on right now. They're ramping up our production facilities to get to a point where we're creating 5 satellites a day. There's no recipe, there's no Amazon book you can buy on how to produce 5 satellites a day. It's sort of a uniquely Amazon problem. One of the things we did and we tested, and the hardest thing that we did, was called the optical intersatellite links, or the OISLs. So this is a laser that sits on the satellite, and you have to point it very, very accurately and deal with refraction, all types of other technical problems, to create a laser link that's 100 gigabits per second. So for those of you that maybe don't know 100 gigs per second, that's what maybe 2 very, very, very large data centers use as a backbone. That's what the AWS backbone uses, for example, lots of 100 gig links. So we've got one of those in space using lasers. I'm also legally required to go pew, 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 whenever we talk about lasers. Don't ask any questions. These allow us to do some very cool things with the satellites. So for example, you have the ability to basically create a space backbone. So you can create a space backbone over Earth You can do things like choose the right place on ground to bring connectivity based upon either policy or where there's more bandwidth. It also allows you to do things like connect cruise ships in the middle of the ocean because there's no ground infrastructure, obviously, in the ocean. So the lasers are one of the hardest things we did, and it was a super large milestone for us. But we can take a step back here and talk about, again, why are we doing this? Why do we go through all this effort? It's not cheap, it's not easy, and what are the customer problems that hopefully apply to you all? So we'll start in urban, kind of central business districts, city centers, whatever you may want to call it. For most customers, there's a good amount of connectivity. You can get 4G, 5G, fiber from a couple of different providers, but we're talking with customers that are still concerned about disaster recovery. So in this case, we're talking about, I don't know, tornadoes, hurricanes, cyclones, whatever keeps you up at night. When those things come through town, there's certain people that want to stay available. So that could be a hospital that needs to provide care to patients, even when the power or water or other things are not available. This can be financial services institutions that need to make sure that their payment data and other things are out. This week we've been talking to a lot of folks down here in Australia, and they've told us how much they love their internet, being a little facetious here. But the outages can last days sometimes, apparently. And so this is a very real problem, even in the places that have the most connectivity. So for a lot of customers we're talking with, figuring out how to back up those connections is very easy for almost anyone to understand, whether you're a financial services institution or hospital or first responder, whatever it might be. As we get out a little bit into, I pressed the wrong button, sorry. As you get a little bit further out from the urban city centers into the suburban areas, you see a different set of problems. So you have less options, the connectivity is less reliable, and suburban can be anywhere from 2 kilometers to 20 kilometers. It just really depends on where you're at in the world. And it can be hard to find that connectivity. Maybe you try to bond together multiple modems, or you have multiple fiber providers. But if there's any one rule of kind of network engineering, is that the fiber-seeking backhoe will tell the truth. So I can't tell you how many customers I've had that they get connections out of the north side of the building, the south side of the building, and then they didn't know there's a bridge down the road. Bridge has an issue, and now both their redundant providers are down. Or they just don't have very good connectivity. It's hard to find, like, is it going to be this cellular provider or that cellular provider that's going to get good connections at this new site we have. Or we're building a new site, and it takes 3 months to get connectivity to a new location. And so these are some of the problems we're seeing even in fairly well-connected areas. Then we get into areas where you traditionally think about satellite communications. You think about your urban, your industrial, you're out in the middle of nowhere and you're not sure if there's going to be any connectivity at all. This creates all sorts of problems that are generally expensive. This could range from loneliness, this could be our multi-million-dollar rigs and equipment will have operational issues if we don't fix those things. This could be the fact that you could have health and safety issues out here when you're out here doing these sort of critical operations out in the middle of nowhere. Then you get into places that are even further out than that. Oceans, islands, these are all places that if you can get connectivity at all, it probably doesn't stay up for very long, and you need good connectivity to do things. So across all these different kind of scenarios, these are all places where Kuiper is focusing on building the next generation of network connectivity. So I'd like to walk through a little bit of the services we provide and how that will sort of get shown to you as a customer. The first thing to understand is that Kuiper is going to do a little bit of everything. So we'll have a service that sells directly to consumers. So if you've got a house in the mountains or out in the outback and you want connectivity there, we can put an antenna on your house and you can get great connectivity. If you're an enterprise and you have any of the enterprise use cases, media entertainment, energy, oil, mining, financial services, we'll do enterprise as well. And then we have a separate set of use cases around public sector, emergency response, government, military, and those types of use cases. So Kuiper is taking the sort of entire gamut of customer problems and working to solve those. And so ordering the Kuiper service is going to look a little bit like this. First, you choose a service plan. The service plan is what you kind of expect from an internet provider. It's your monthly cost, that's your, what you buy. There's speeds and feeds. One of the things we are doing that's a little bit differently, and we announced this at reInvent last year, is private connectivity. So we have the ability to create connectivity almost anywhere in the world that doesn't touch the internet. You can bring that directly into your AWS environment or back into your private data center. So you can set your location of those things. We'll make sure that capacity is taken care of and we're not oversubscribing services, and making sure that we give every customer the experience that we've promised them. Then that ties into the hardware. I'll show you on the next slide here, we've got 3 different sets of hardware you can choose from, different mounting options, different accessories, and different ways to power these units. And then if you want to do the private connectivity, you can create your IP addressing options, where you want this traffic to route, and we'll talk a little bit in that detail as well. So, the terminals themselves, this is where a lot of our kind of pride and joy is at. They, in my opinion, are delightfully boring. We brought one of these out actually to reInvent one year, and you look at it, and it's just a flat white panel. And it's good because this is what Amazon can do, right? We take what we've learned from mass manufacturing other things, Kindles and Fire TVs, and you take it to a device that historically costs thousands of dollars. And so we can do this now at much, much lower costs. So for example, this middle unit in US dollars is less than $400 for us to produce. And so these also don't have any sort of installation instructions you have to worry about. They go on a roof, they need to see the sky. There's no motors, there's no positioning. We figure all that out through our networking. And so from there, it's really about figuring out what your use case is. We're talking with folks that want to do IoT and monitoring. We have people that want to put it in a backpack. We have people that want to put these on the side of a road and power it with solar. So we've got this small unit here that's about the size of a DVD case. This middle unit, which we have actually a replica in our booth you can come see, that's about the size of a MacBook. And that'd do 400 megabits of speed. So then if that's not enough for you, we got the enterprise unit. The enterprise unit's like a oddly shaped skateboard. And so that's one that will do up to a gigabit of speeds. It's going to have better signal quality because it's also got 2 antennas that are separated on it. So it really depends on what you need to do from a customer perspective. We've got the options for the terminals. The other aspect here is, this is one of the decisions that Kuiper has made, is we put the complexity into the satellites. We know that across the world, the upfront cost it takes for connectivity is super important, right? We're investigating things like the cost of an LED, because maybe in Indonesia that could mean less customers. And so the idea is here, we're building hardened, ruggedized things that we can use for multiple use cases, but doing that at the most affordable price points we can. Which leads into another question that we often get. We're not the only satellite provider, we're not the only internet provider. What's different about Kuiper? The way I like to think about it is around these 3 buckets. So one is the high performance. When I order internet connectivity, I really just want high speeds at a low price. That's what a lot of people want out of internet. And so we're making sure that we've ruthlessly designing to optimize for that. So one of the things that's interesting about Amazon is our scale. So for example, we have the ability to build chips inside of Amazon. We've done that with Graviton and Inferentia. A lot of the stuff that runs underneath EC2 and networking is all custom-made chips. So we've taken that approach to Kuiper, making sure that we build the right everything from the ground up inside of Kuiper to make sure we can get the right price and performance ratios. So that's why the terminals, we think, are going to have the highest performance with the lowest cost. We're also really focused on security. So we're building in features like end-to-end encryption. So when you send traffic to our terminal, we encrypt that traffic, and we don't unencrypt it until it gets to our destination. So this means we've got built-in encryption and we're doing things that other providers aren't doing there. We also have the ability to do these private networking options. So we start working with like regulated utilities or folks that really care about security or intellectual property. We're able to do new things with security that make their lives simpler. And then a lot of the feedback we also get is, we want you to answer the phone when we call you. We would like enterprise support. We would like to be billed like an enterprise because we are a business. And so you can take the things we do with AWS, the things we've done with Amazon.com, those expectations, and we're working from that level of expectation for the way that we're going to help our customers. So that means things like management tools, building out APIs that are web scalable, and the things that you would probably expect from us presenting at an AWS conference. Also, I can talk a little bit about how it works. So some of the fun, more technical parts here. So one of the most important parts of the constellation we're building is that we're in low Earth orbit, or LEO. So for those of you that aren't maybe space nerds, how many are space nerds? All right, so about half the people in here are space nerds, that's great. So for everyone else, low Earth orbit basically means we're very close to Earth. So our shells are 590, 610, and 630 kilometers away from Earth. If you think about traditional satellite services, they're 36,000 kilometers away. That's where you get this thing where you change the channel, it takes 2 seconds. That's traditional satellite. This is not that. It also means that these satellites go around the Earth around 15 times a day at 27,000 kilometers per hour. So it means you have to design things slightly differently. But it also means that it acts like a normal application. You can do gaming, you can do phone calls, you can do Chime for those of us that love that service. You can do all these kinds of services without having to do any special satellite things. It's going to feel like another cellular or fiber connection. And so when I mentioned the speed of the satellites, what that means is every place where you can see a terminal, you need ground infrastructure. And that's the way this works. So you go from the terminal to a satellite, back down to the ground. From the ground, we take it to one of our processing centers, and from there it goes to where the traffic needs to go. You only spend a handful of milliseconds in that space area. Most of the work here, most of the complication is actually on the ground. So the hard part is how do you build a global high-speed backbone network? For us, that's great because we've already done that. Amazon has a multi-100 gig set of infrastructure that goes across the world. This carries Prime Video traffic, this carries all the AWS backbone traffic, and it's also going to lay the backbone for the Kuiper network. So you can think about the fact that if we need to put an antenna in the middle of nowhere and make sure it's connected through a high-speed network, it's a lot easier for us to do that since we don't need to build our own global network. And so that's where us using AWS starts to help customers a little bit more. We also have this ability, I mentioned earlier, to do private and public connectivity. So as I mentioned, the connection goes from the terminal to a satellite back down to the ground, and then we go to our processing center. So this is our Kuiper network core. That Kuiper network core is built on AWS in a region. And so depending upon where you're at, here in Australia, that would be Sydney or Melbourne. Across the world, there's another 20 plus regions that you can choose from. From there, we can choose where we want that traffic to go. So we can go directly to the internet. You can kind of think of this as being like the world's fanciest Ethernet cable. You plug in one side, and the other side you get the internet. Or you can also go from that Ethernet cable to your data center, or to another cloud, or to all types of locations. We can also keep it within AWS completely and hand it off into your sort of virtual private cloud or VPC environment. So this is helpful for folks that, again, security, regulation, data lakes, all those kinds of things. We can wire this privately into those types of use cases. So we should probably talk about use cases a little bit. The first thing we see is just plain old connectivity, primary and backup. This is very, very simple for people to understand. Getting connectivity is hard, we can make it easier. You can think about how long it takes for fiber to show up to a building, and you can think about Amazon shipping you a device, and sort of the style that Amazon ships devices. We can get connectivity places very quickly, and we can also back up those sites. So whether that is an office location, we're also working with cellular providers. So how would you put a cell station, a new radio tower, in a hard to reach place? So Kuiper can help those types of customers do that. We're also talking with the customers that want to do their own 5G in remote locations. So the 5G can cover something like a mining site, and then Kuiper provides the connectivity back to the internet or to a data center. And then you've got all your sort of plants and IoT type locations. But the sort of story is both primary connectivity and backup connectivity we can do quite simply. So it's worth talking a little bit about internet connectivity and how this works. I'm going to show a quick demo about the 2 proto-flight satellites we did and the testing we did down in Texas to verify the satellite connectivity.
Back room, this is McAllen. Are all the pre-checks looking good? Copy, thank you. Contact start.
Two-way.
We have two-way.
We are getting internet traffic via the Kuiper network, navigating to Amazon.com now.
Andrew is executing the demo. Right on cue, the heavens have opened up a little bit and it is starting to rain significantly harder than it was earlier. Contact is starting now.
We have
Switch
two-way.
over. We have two-way.
All right, confirmed. We have internet access via the Kuiper network, and I am searching for air rocket racers.
Andrew executing the demo.
Page is loaded. I'm adding to my cart, and confirmed.
And Andrew just completed the first successful purchase from Amazon.com. Contact start.
Two-way.
We have two-way.
All right, we have internet access via the Kuiper network. Joining the meeting. All right, cool. Flight, this is McAllen.
Go McAllen.
I wanted to let you know that I am joining this time meeting right now via the Kuiper satellites, which are passing over the customer terminals as we speak.
Congratulations on such a huge milestone.
Thank you.
Nice job, team. Now let's go build some more satellites.
Awesome. Thanks, guys. McAllen signing off.
So that's basically the work of 1,000 engineers working over 5 years to get a chime call to work, which if you've ever thought it's long to join a chime call, sets a new record. But when we talk to customers, we hear these types of stories like that kind of repeatedly, which is we're in a kind of hard to reach place, but we want to do basic connectivity use cases. We have folks that need to do video calls so they can get expert help. We have people that need access to their productivity tools, or they want to access their email or Salesforce or project planning tools or whatever it might be. And the impact we can have for these types of folks is pretty large. We're hearing stories about it can take hours or days to get out to these remote locations, and you find out that we don't have the expertise to fix this. And if you could do a call real quick, we might be able to solve that immediately. Otherwise, we've got to bring people back, bring more shifts out, bring back people just to solve something that you could solve with essentially a FaceTime call. We're also hearing locations where, for example, with media entertainment. So people are out there doing remote filming, and maybe the production studio people can't all be on site, but if you could show what's going on site, then more people could join. So you can also bring the remote areas to centrally connected areas, if you will. And so we're seeing customers talk about this across a wide variety of use cases. Whether this is workers out doing mining, this is folks going out to wind farms and getting on the boats on the way there and back. And this is just basic, the connectivity of the internet, which is great. Then you start to get a little bit further out and get a little bit more specialized. So we're talking with folks that they have these, whether that's a oil rig or mining heavy vehicles, these things can be very expensive, and when they fail, they're even more expensive. And so it's about what could you do if you had better connectivity out there? What sort of, this is almost like an IoT type play, which is, can we start putting more sensors on things? Maybe you've got a standard definition camera, but if we could put an infrared camera that's even better resolution, are there problems we could fix before they could become a real problem? Can we make the lives easier for the folks doing this type of preventative maintenance? Can we do sensor-based automation? And when you have bandwidth, you can start thinking about these types of solutions to these problems. And you might have a person that's been going out to this remote area for every day for years and years and years, that you can essentially help that person do that job with sensors and a bit of connectivity. Especially, this is where we see use cases for that kind of smaller antenna that you can connect in very easily. Then we get to sort of this quality of life improvement. this is where the intersection of doing good things for business and doing good things for people both make sense. And these are some of my favorite use cases to work on. So if you think about this use case in the upper right, we're working with folks around the world on remote healthcare. If you think about the amount of radiologists that exist in places like Africa or Indonesia, other places, they don't have enough healthcare professionals to service the population. And there are people that will get on a phone call and do this as a service, but you need bandwidth in order to do that. This could also be the case that you've got a remote worker that hurts themselves out somewhere far to reach and they just need to talk to someone, the EMT that tells them the right way to tie something up. So it's good for people's health, it's also good for business. Then you think about bushfires. How do we help monitor and figure out what's going on in these remote locations and do that with higher accuracy? Can we put cameras out there? Can we do detection? Then you think about, I was in Port Hedland this week with all the FIFO crowd, and it can be lonely out there without connectivity. What happens in the United States? We've got the same type of deal with offshore workers. If you're out working for weeks or months without connectivity to your family or without access to even entertainment, you may not want to be out there. And so it makes it harder for folks to employ people, harder to keep them, and just giving them internet connectivity and connecting them to their families. We hear similar things about, for example, the crew that works on cruise ships. The customers actually get a better experience when all the crew's happy. And then also just access to information. So we're talking with some folks that, for example, want to do monitoring of an HVAC solution, but it happens to be right next to a school. And so if we're already giving connectivity to this air conditioner, we should probably give access to the school as well. It doesn't make sense for an air conditioner to be more well connected than the kids are. And so for those types of use cases, it makes sense for us to sort of bundle the connectivity and maybe a hotspot for the local folks. And this is where you start to get into some of the areas where we bridge the digital divide. Some of the statements that were made this morning around the First Nations folks. So there's a lot of very interesting things we can do that help the business use cases as well as the right thing for people across the world. Super, super exciting. I'm always asked about machine learning. And so, these are actual things we've heard from customers, which is, if you think about a lot of these industries, they're intentionally away from city centers. You think about agriculture, mining, wind farms, people don't want these things next to their houses, so you intentionally are in the middle of nowhere. And so a lot of times you've got someone there that they can put their hand on the side of a machine and tell you it's doing well or not. They know the way that the hogs are moving, whether or not they're thirsty or sick. You've got folks that have these kind of superpowers. They know that industry so well. But the companies are trying to figure out, as these people retire or we need more of these people, how do we really make that scale? And so the idea is here, you add more sensors, you add more ability, more analytics, and you can start to put machine learning in between that person and these data sources. And so in some cases, you may run out of farmland, or you may run out of new places where you can do these things, and by increasing the yield, increasing the output, you're able to get better business outcomes. In some places this means taking better care of the animals, or growing more plants, or letting less machinery go into disrepair. And so this is one of the interesting areas we're seeing customers start thinking about that next wave of transformation that they could do by collecting more data at the edge and then putting that into the cloud, and maybe they need to do that privately. So speaking of private connectivity, there's a lot of use cases we're talking with folks, and I'll tell a couple stories of customers we're working with. So they're a power utility. Power utilities are old businesses, because as long as we've had electricity, there's been regulations on how to do that safely. And if you want to do interesting things, like put that in the cloud, use new automation, do machine learning, it raises a lot of questions in those communities, because they said, we've been distributing power for hundreds of years, why do we need to take these risks? And so with Kuiper, we're having a conversation of, well, if we can take that, if we can provide you new data sources and connect your remote locations easier, and we can keep that off the internet completely, that just gets rid of a whole set of questions that they have to answer to their security and regulation type folks. It can make that conversation easier, and you can focus the conversation on the right things that help you kind of move forward. We're also having conversations with some of the power utilities that if they go down and maybe they represent the entire country's power, where do they get help for booting back up again? So the idea is we can use Kuiper to connect to potentially a different country, use a different country's power supply to get you booted back up. So some really super interesting things we're doing around the privacy and security. And like I mentioned, this is sort of job zero for us at Kuiper. So in some places, you can also then take the devices at the remote locations away. So if you need encryption and private connectivity, usually through a VPN, you've got a small firewall. In some cases, we can say, well, that's less power, less devices you need to run at that remote location. So you can do that all natively, essentially just with that one terminal that we've got. And then you've got mobility. So mobility has a number of different problems that we're going through. That could be airplanes where connectivity is hard to get into. This could be workers on airplanes. This could be media entertainment, helicopter trying to film things in remote locations. We're also working with folks on the land side of things. So can we put a sensor inside of these heavy vehicles so that we can do better introspection about what's coming off the CAN bus? Can we go and can we put an antenna on the emergency services vehicle so when people show up to help a patient, they got immediate access to all the personal health information for that person, even if they're in remote locations. We're working with folks that want to put these on the buses and the light vehicles for just asset management and tracking. And then you think about the mobility kind of things around boats. So offshore oil platforms that move and do oil exploration. You think about shipping containers that want to do IoT tracking of the containers and making sure that things stay cold or things didn't get shaken up or whatever it might be across the entire ocean. You've got cruise ships where we all love to pay for internet and get access to loved ones so that our phones automatically upload our videos from the cruise ships. And so mobility is going to take a little bit more time for Kuiper, primarily because there's two things that happen there. One is as things move, there's a Doppler shift, so it changes the frequencies. So those terminals that I was talking about that don't need to move, when the frequencies change, we have to do slightly different things inside the hardware that we have to account for. But also the way that we're going to do bandwidth management. So I mentioned that the promises we make to users are super important. So every service plan that gets purchased basically assigns capacity in the system. Now, when people buy things that move around a lot, that just uses capacity in many different areas. So those are kind of the two challenges that we're working through on the mobility side. So you'll see mobility service come after launch, most likely. And also likely with specialized hardware for some of these use cases around airplanes and automobiles and other type of use cases. And so some of the things that we're seeing, the way that we're working with customers is pretty varied, but this is kind of the formula that we see, which is figure out your use cases. One of the exciting parts is we go and talk to customers and they go, yeah, we've got planes, we've got boats, and we do power distribution, and we've got financial services payments that we need to make sure get paid, and we've got remote workers that need to be able to access email, and we've got on and on and on. We've got 30 use cases. It's super, super exciting. Usually the feedback is, let's focus on a couple of those. Is it backup? Because backup's pretty simple for folks to understand. You want to stay up? We can help you do that. We don't use the same networks. Or do you want to work on the really hard one? Do you want to go figure out how to do machine learning at the remote edge and sort of figure out how to scale your workforce by introducing new computing methods or whatever it might be? Either way, we're happy to do either one. But that is, let's focus on a couple. We're really interested in hearing from early customers, so all of you hopefully, because that helps us build what we need to build. And also we want to make sure that when our satellites go up in the air, you all are ready to use it. So we're incentivized to help you figure out your problems, your processes, all the sort of gatekeepers in your organization, whether that's finance or security or networking or procurement or legal. We're happy to work with customers in advance to make sure that we can go through those problems so that customers are ready to use us more quickly. And so, we're at the booth here. You can go to the data areas, the big orange section. There's two very large rockets that let you know that that's where we're at. And we're happy to chat and talk with customers in more detail. And yeah, so thanks everyone for coming out and appreciate it. And I think, yeah, thanks.
Please keep that applause going for Nick Matthews. Thank you so much. Keep that applause going. Keep it going. Fantastic. Wonderful.